All right, beautiful people. Today we're going to be talking about side-side-side triangle congruence. So how can we use SSS to prove triangle congruence? So quick thing, SSS stands for side, 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 which means you have to have three sides marked as congruent. So a quick recap. We already know that if we have side angle side, then we have congruence. So if we have the angle in between two congruent sides of two different triangles, then we have congruence. Today we're going to talk about side-side-side congruence and what's called hypotenuse leg congruence, which I'll talk about in a minute. I do it after I talk about side-side-side, but you should know that those are the three that we're talking about. So we've already done this one. We're going to talk about side-side-side and hypotenuse leg today. And then tomorrow we're going to learn two new ones, okay? All right, so we'll start with the side-side-side congruence theorem. All right, the side-side-side congruence theorem says that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent, just in general. Again, like I said yesterday, if you need to restate or rephrase it so that you're writing less, these are your notes. It is really 100% about you. I'm going to abbreviate it when I write it in my notebook. So you do you. Okay, so here's my example. I've got 1, 2, 3. And then I've got a second triangle. 1, 2, 3. I know now that these two triangles are congruent. And let's say that this one's called A, B, C. And this one's D, E, F. Okay, then I could say that triangle ABC is congruent to. Now this is where it gets tricky. I need to make sure that the sides are lined up. So AB has two lines, so I need D and E. Triangle DE, which leaves F. Okay, so notice when you write the triangle congruent statements, you need to make sure that you line up all the things that are congruent to each other. So that means angle A has to be congruent to angle D. Angle B has to be congruent to angle E. Angle C has to be congruent to angle F, and that's because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay, the angles are congruent, the side lengths are congruent. All right, so that's the side-side-side congruence theorem. Let's use it to see if some examples are congruent. All right, so I've drawn 3 examples. Go ahead and pause and make sure that you draw these 3 examples. And then we're going to talk about deciding whether or not they're congruent, okay? All right, hopefully you've paused and you've drawn those 3 examples. So this first one, I've got triangles ABC and ADC. So I'm asking if they're congruent by side, side, side. So I've got one pair of sides, that's the ones that are marked with 1. Got a second pair of sides marked with 2. And then I have this third pair of sides, AC, because AC is congruent to AC. This is called the reflexive property. Basically, it means, hey, something is congruent to itself. It's a reflection. So this should have 3 marks in the center. So now I've got side, side, side. So I can say triangle ABC is congruent to. Now remember, I want to make sure that these line up. AB has a 2 marked, so I need AD, which leaves C. Okay. By SSS, side, side, side. Okay, let's try the second one. Now the second one is a little harder to see, so what I'm actually going to do is I'm going to separate it into 2 triangles. And this is honestly the best tip I've ever known, is when I see 2 overlapping triangles, I separate them. I actually show the separation on my notes, okay? So I'm going to start by separating ABC. And this one has 2 marks of 2. So I'm just going to do 4 marks there. And then I need the other triangle, which is on the right-hand side. And I've got this one. And again, I've got D, C.